Okay. Well, I think we should get started. I'm trying to stay on time. And as I mentioned, we have a couple questions on Slido. This being the first one, it's in the Slack channel if you wanted to respond to it. And yeah, share the results as we go. So just the usual reminders of the code of conduct. Hopefully we've all seen these slides a couple of times already this week. And the representatives here, if you experience or witness any harassment or unprofessional conduct. And just a reminder, those on Zoom, you could keep yourself muted when you're not speaking, but it'd be great to hear your voices as well in the room. And for everyone in the room, I think there's lots of mics, but just trying to, yeah, keep the background noise down and speak up so everyone can hear the conversations here. Hopefully we can have some discussion in the session. I'd really love to use the Slack channel, so I've put it on there. And yeah, looking forward to hearing all of your voices in this conversation. And so today, I'm excited to be talking about what citizen science looks like with the Rubin Observatory as we get close to having data from Rubin. I'm presenting on behalf of the Rubin CitSci team. This team is multifaceted with representatives like myself from the education and public outreach team. We also have Eric, who's on Zoom. We have members from the community science team. So we have Brian and Becky, who are also on Zoom, and you'll hear from them, as well as in-kind contributors, Chris and Toyosi from Zooniverse, as well as Afrojita, who is also on Zoom. And of course, there's we get lots of support, advice, and input from many members of the Rubin community, which we are very grateful for. A little outline of what we'd like to do today. I'm going to give a little introduction about citizen science and hopefully just kind of do a bit of a big picture and get our kind of minds in the right frame of mind for this part. Brian is going to speak about briefly about CitSci and AI. And then we hope to have a bit of an interactive discussion, which has either two modes, either chatting with the people you're sitting with, or if you're not feeling in a chatty mood, a bit of an exploration of some existing projects, just to discuss some of the possibilities and options about what Rubin CitSci might look like for your research and how we can put this all together. And then Becky will give us a little bit of a walkthrough of some of the resources we have developed, and I'll touch on how it connects to some of the support we can provide from the CitSci team. And hopefully there'll be some time for some questions and discussions along the way and at the end. Okay, so starting off very big picture, what is citizen science? So citizen science, by this definition from 2015, which I really like, describes it as an open form of collaboration where members of the public participate in the scientific process, identifying research questions, collecting and analyzing data, interpreting results, and problem solving. And I like this definition because it incorporates the various avenues for the public to get involved. This is a very multifaceted exercise, and there are many ways for people to participate. But I would also like to know what you think of CitSci. And so again, here's the little Slido link, which is also in the Slack channel. And I would love to hear how our Rubin community is thinking of citizen science. So if you want to toss in some thoughts and ideas there, it would be great to have our Rubin definition as well. And again, it's in Slack. Again, sticking to the big picture, I think it's important to remember that citizen science is much more broad than astro, and how it looks in different fields is very varied. So a couple examples from non-astro circles, you have things like promenade in the national park, where you put your phone on a little mount to take a photo. And this is where the public is really participating in the act of data collection. You have other cases like iNaturalist, which is a big global flora and fauna identification project, where you have a lot of public participating in the analysis and identification. And you have things where you have some classification. So this is node code breakers from the Zooniverse looking at features in lymph nodes. And so just remembering that the landscape of citizen science and how the public engages with it is very varied. I mentioned the Zooniverse here, and I'm sure many, if not all of you, are familiar with the Zooniverse, have participated in it, and perhaps used it. But just in case, this is a very well-known citizen science platform that hosts a variety of projects and has a great interface for both the science community and the public. And the Zooniverse is one of our in-kind partners for this project, and we're excited to be collaborating with them to really bring citizen science to the world. The Zooniverse is definitely more than just astronomy projects. So here's just a bunch of their projects that they currently have. It's sort of loosely classified them by area, and you can see the fact that they really span a whole gamut of options and types of exercise and fields. It's far more than just astro. I think it's important to remind ourselves this because there's a lot of exciting stuff going on, and there's a lot of techniques and ideas and approaches that exist in other fields that are interesting to apply to our astro side. Of course, everybody in this room is probably more interested in the astro projects, and the ones on Zooniverse, there's a bunch there that I've tossed up that are tend to be kind of the classification identification type projects. Of course, there are other astro citizen science projects that exist in a different framework. So there's ones like the SETI and Unistellar project. So hopefully you guys went to the Star Party last night, saw the really cool Unistellar telescopes. And so that's a project, where you have your volunteers contributing the observations in a kind of different method. This is a really unique and powerful method. There's a lot of insights to be gained from it. And coming from the EPO side, I think this is really, as a scientist on the EPO side as well, this is really where the exciting interface is the fact that this can be really meaningful to the public, meaningful to the scientific community, and really mutually beneficial in exciting space. So that coming to kind of question of why does the public want to participate? I think it's important to emphasize that people do want to participate. So these are the numbers. I think I grabbed them on Monday from the Zooniverse. And so you can see the fact that you have like 800 million classifications and almost 300 million volunteers. So I like to think about the number of classifications. If you assume each of those classifications took 1 minute, that's 1,500 years of effort. And so the power of what people can do. And also, a fun aside, I'm slightly recycling the slide from a talk I gave in late May at the Rare Gems and Big Data Conference, and so I updated these numbers. And so between late May and now, there's been 11 million classifications and 15,000 new volunteers, which is it's fun to see the the engagement that people have. The motivations for why people want to engage are, of course, varied. There's lots of reasons that people come to the table to participate. But really, some of the key ones are engaging in the scientific process. Also, people are very excited to see new data and fresh data, so of course, when Rubin comes online, we'll have a lot of new and exciting data to share with people. I think we do have a challenge ahead about how to keep people excited for the duration of our survey, but we will have lots to work with. And engaging with science and the scientific community is an important aspect. I will also emphasize that having pretty pictures of astronomy people like, but is not necessary. So here is an image from Planet Hunters. Of course, beauty is in the eye of the beholder, but I wouldn't necessarily say this data is the most visually appealing. That is not probably the most strong incentive for looking at this. And so that's not necessarily an essential part of a successful project. And so coming to Rubin and citizen science are really a great combination. Of course, we know that Rubin is going to be a source of a huge amount of data, and there's a huge amount of a wide variety of science cases, which I think gives the public the opportunity to find the things that they are interested in to participate. But the aspect that I'm most excited about is, Rubin has the intent to discover the unknown. I think this is where citizen science can be really powerful. We have some exciting times ahead. There have been past discoveries like green peas and SDSS, which is discovering an unknown, and I'm so excited to see what things we didn't know to look for that we will uncover with the help of volunteers through Rubin. And so, of course, here's just a little quote here saying, the fact that EPO, we anticipate a dramatic increase of projects with Rubin, and it's going to give the public an opportunity to deepen their engagement with astronomy. This is the EPO mission statement, and again, I think these pair so well, and the fact that this is a chance for the public to engage with Rubin, but not only just engage with Rubin, but engage with the discovery process of Rubin and the exciting science to come. So of course, who is citizen science for? It's for everyone, everybody in this room and beyond. For our scientists, it's a vital and unique tool for understanding this complex data. For educators, facilitators, this is a way to bring Rubin science into your communities, classrooms, and what other spaces you share. And for the public, it's a chance to get up close and personal with the data. And again, not only just participate in the research, but participate in discovery. And so I'll just add one note. CitSci is awesome, but it is far from perfect. And so I've been calling it citizen science throughout this talk. That is not the best term. Citizen science can be is an exclusionary way of describing it. Just so you know, our approach is to use the word citizen science when we're talking to our science communities, because I think that's a well understood term without a great alternative. When we talk to the public, we try and use active language and encourage volunteering, and perhaps not emphasize the need for citizen science. And we'll also say citizen science is a great space to invite people who don't necessarily traditionally participate in the scientific process to be part of it. But that doesn't happen passively, and we're excited to take active effort to encourage people to include. So this is a map of the current Zooniverse volunteers. I am really excited to see how we might particularly change the South America portion of this map. Okay, so I'm just going to throw this up one last time as a last chance if you want to add something to the word cloud. And I will hand this over to Brian, who's online. And playing your test up.
Hey there, good morning, y'all. Let me know if I should change my volume here speaking. It's good to see everybody. I appreciate your time for our chat today. So I just wanted to spend a little bit of time talking about some of the, not even the history, because it's not super deep, but just I guess the current state of the art when it comes to mixing machines and humans in this space, so AI and citizen science. I guess maybe online and in the room, I won't be able to count the room, but could I just get a quick show of hands of people who have done machine learning or artificial intelligence before?
Say what, we're a quarter maybe, Brian, in the room?
Okay, and a few people. And has anyone done artificial intelligence with citizen science? Okay, so we got a couple. Okay. Well, I know I appreciate your participation there. That's first time we asked that question. That gives us a little bit of an indication of where our support should be planned. So yeah, Claire, could you go to the next slide? In what I've been looking at, so I've been doing AI for a little bit short of a decade, but I haven't been doing a lot of citizen science until a couple of years ago. And what I've been looking into, it really looks to me like it's quite an open space in combining these two methodologies. And there are some groups, some projects that have been working to push the envelope. So I have some examples here. So Supernova Hunters, for example, presents a few candidates at different times. And then they have a CNN or convolutional neural network look at these images that's trained somewhere. And then they have humans look at these images, and then afterward they combine the accuracy scores. So that's one that example is saying let's treat the machines and the humans separately and then combine them. Gravity Spy, which looks at spectrograms from LIGO events, and I think there are a couple other projects that have tried this or are working on it, have sort of an active learning loop where machines and humans have more of an interaction. So when a human or a machine classifies something in a way, then that information is sent back into the loop for the humans and the machines to maybe look at, or maybe it's taken out of the loop. So there's more of a loop there when it comes to Gravity Spy. And then Zubot is a recent example from that is more on the side of taking what humans have done in training or looking at morphologies, 3-color images, morphologies of galaxies, and then building an AI model on top of that. So these examples, I hope, give you a sense of where the landscape is. There aren't a ton more projects that are doing this. I think there are a lot of people who are thinking about it, but there aren't a lot of projects that are publishing about this topic and their new methodologies. Go to the next slide. So I think it would be fun if there's time today, if people are thinking about what their what their CitSci project will be. It might be fun to brainstorm how you would do that. So I recapitulate at the top here 3 of the main approaches to this. One is humans make a training set, and then the AI uses that, and then it goes on to do future predictions. Or maybe an AI prepares a training set, say there's already some training data out there, but it's not really enough, but you get an initial method that can select objects for humans to then look at. That's sort of the opposite direction. And then there's this active learning, sort of active feedback loop that you could also imagine. There are various levels of infrastructure that are required to do these different kinds of things. So that active learning loop, my understanding is that there isn't a lot of software out there that can do that automatically for you. So that kind of thing would take some doing, but it may be very worthwhile. And I know a few people are working on that. The other 2 methods that I mentioned are a little bit more well established, because it's a little bit easier to imagine doing a training and then sending the data somewhere else or the models somewhere else. One really important point that we see in the literature, it's been documented in multiple places, is that if humans know that you are taking what their work and using it to train an artificial intelligence, they are significantly discouraged. Maybe that's necessary for your work. Maybe there's another way to do it. Maybe this is an opportunity to think creatively, but something to be aware is that they could discourage volunteers from participating. And I'll just reiterate that integrating AI and CitSci is kind of an open research area. I think that's all I wanted to say, and I'll be around for this entire hour and a half, of course, and then you can always find me on Slack to talk more. Thanks.
Thanks, Brian. Maybe we'll just also just pause to see if anyone has any questions right now before we jump ahead into the next section. We can any thoughts, Brandon?
I have a quick question.
Yes.
Brian, do you know what the sense of the discouragement is with folks that don't want to participate when they learn AI is involved?
Is this Bob?
Yeah.
Oh, hey. Yeah, so that's a good question, and I would refer to one of Claire's earlier slides, which is people want to be a part of the scientific process, and they want to feel like they're part of that moment of discovery. And I think adding a machine between them and the discovery shunts that a little bit. There may be ways to communicate about this to people. Actually, I'm glad you asked this. You're making me think a little bit more. There may be ways to communicate to people more about the scientific process that maybe normalizes the use of any model, because we use models all the time, whether they're AI or not, and models are used in creating training sets that go into citizen science projects. So I think we at least would want to dispel the idea that there's a gap between humans and the discovery process. That's my hot take.
That's really helpful, because at least it sounds like there's an opening to make progress here.
Yeah, and actually, I'd be really interested to. I think I'm due for a conversation with Aparjita about this, because I think she's working on this a bit. And yeah, how do we how do we find that space where, like, at least in the next, 10 years before AI has taken over lots more stuff, how do we continue to make space for this intersection of AI and citizen science? Yeah.
And I think Apertita will comment on that in the next section as well.
Hey, Colin Chandler, Active Asteroids. So we have an AI assistant. We're very careful with our language about this. Also prototype. So we're trying to couch stuff a lot. We also polled like our top users, especially the ones that are co-authors on our papers, to ask them about their feelings about it, etc. You kind of mentioned like if they're aware of it, we did toss around the idea of not saying that we're using AI, and that seemed like really an impossibility. Like it was just terrible to even dance around that, or even to imply that we were doing that. But is there any guidance or anything like that anywhere for expanding on this? Because we do feel a little bit like we're going without any guidance. We've asked, if there's other suggestions for. We asked our users, do you think it would be better to have two different workflows, like one that's completely background, we show people images, they classify them, so we've been using it as a garbage detector, basically. So it's taking out stuff that hopefully makes their experience better. But some people feel so strongly, we considered having like a parallel workflow that was completely untouched by AI. Have you heard about that at all, or do you have any suggestions?
Let me just recap, make sure I get where you're coming from. So in your project, part of what you've been experimenting with is different ways of communicating with your volunteer community to see what they care about. And that has led you down a few different roads of things to experiment with. Is that right?
Yeah, that's fair.
And you're wondering, is there any best practice out there?
Yeah.
Okay. So in what I've been reading, I have not found sort of like a real standard best practice. I should double check my notes, but I don't even know if people are giving a lot of advice in their papers or a lot of what they're talking about. So you may be at the vanguard. Let me, which is good and maybe not good in some cases, but the room for building. Maybe you and I can connect on Slack, and I can try to understand your situation a bit more.
Sure, that'd be awesome.
Thank you.
I'll also add that this is exactly the kind of thing that we hope to, just as we want to build a community of volunteers participating in Rubin Citizen Science projects, we'd also like to be building our community of project leads who are doing citizen science projects, so we can have these conversations and really have that kind of productive conversation about what's working and what's not working.
Okay. I joined partway through, but I think Mark Kushner at NASA has specifically been thinking a lot about this. I think he actually has some sort of draft Google Doc that is all his advice for best practices on how to run a citizen science. And NASA has yearly workshops where they physically bring all the PIs together, and it's exactly called, like building the NASA citizen science community, but from the PI researcher side. So
I think, yes, and then I think we're specifically talking about AI and CitSci, and okay. I think it'd be cool to see what Mark has in that on that approach. And do you have a question too? Sorry, I saw hands over here before.
I'm curious. So I'm Dan from LSST Discovery Alliance, and I'm curious about this thought that I had that thinking about Zooniverse before this emergence of AI recently, it used to be said that these types of programs on Zooniverse are really great because humans are so good at pattern recognition. And I could think of like kind of the fun example of like pareidolia, where we see the patterns of things and faces and things, right? Is it becoming apparent now with AI that the AI will be just as good or better at humans at pattern recognition? Is that a fear that we have?
So tough question. A couple of quick thoughts. AI, I think, is really great and demonstrably so across science for just baseline classification tasks, where if you say, let me find this object and then I'm gonna go do sort of real science with it, like do a measurement or do some follow-up observation. What it's not good about is interpretability at all. and even in like a very rigorously statistical sense, it is an open problem to have error bars from an AI model classification or any other kind. I would say that if there's enough training data, which is hard to get in a lot of cases, an AI model for classification to follow up things is probably going to be a best bet for a while. But we don't know what when it chooses something, we don't know why it's choosing a thing. And so when you have not a lot of training data, and when you really care about why something was measured or selected by an AI, by a thing, then I think humans are coming out ahead. That's my from an AI perspective, that's my view of the state of the art there.
Aphrodite, I noticed your hand. Wanted to chime anyone?
Yeah, sorry. So my comment is a bit related to the previous question, which was about I think whoever was speaking, so I'm not in the room, so I'm not sure who's speaking, but about whether you tried not to tell the citizens that AI was involved. And I just want to say, from a best practice point of view, not telling citizens up front is the biggest turnoff for citizens. So basically be upfront about everything, let them make the choice, what they want, what they're comfortable being involved with. And I think it's great to hear that you were doing that kind of liaison to really understand what your community's wishes are. But generally speaking, I think honesty is the best. But we had difficulties, and I'll come to this a bit later, in even presented simulated data, because we don't have strong lenses en masse to do kind of training. So we simulated stuff, and even that was something they weren't happy with not knowing or knowing after the fact. So generally just be as upfront as possible. So that's all I wanted to say. Sorry, it's a bit out of sequence with the last comment.
My name is Christine. I'm a business manager here, so I do have a science degree a long, long time ago. So I'm interested in citizen science, and I'm actually a consumer by using bird apps and watching the bears on explore.org and participating in all that. So as a consumer, I know that they're using AI on the Merlin sound app when it recognizes or supposedly recognizes a bird. And then I feel like it's up to me as a person to say if it's right or not, right? And to not log that if I don't actually agree with it. So I feel like a participant in that case, but nobody's telling me they're using AI. Of course they are, right? But like with the bears, I feel strongly about, no, don't tell me who the bear is. That's what we're doing as a community, and we're watching this, and we're participating in, watching their behaviors and their interactions. I don't really want AI involved in that at all, right? But if you're like using it to weed out garbage and to direct people the right way, yeah, I mean, that makes a lot of sense to me.
Yeah, no, and I think that's a really good point. And also the fact that, I think one of the things that we have with Rubin, of course, is the fact there's so many different science areas, and the fact that, integrating these techniques and everything is going to be kind of custom to each of these areas and things like that.
Feedback from Zoom. I'm trying to post a chat, but it's completely failing. So I'll just read it out what I'm trying to post. Mitigating discouragements might be helped by feedback to the participants that their feedback contributed explicitly to each discovery, i.e. their name is on the paper.
Yeah, I think that helps. And I think we'll go to the next section, because I think Aaron and Aphrodita might have some comments that kind of feed into what you just mentioned there that might work out well. So just looking forward, there we go. Our exciting results from the word cloud that we created. I haven't looked at this yet, but this is awesome. I think, the key points there: excitement and discovery, as well as community, and Galaxy Zoo collaboration opportunity. This is great, and I think this is really reflective of kind of what we on the CitSci team feel. This is an exciting time for discovery and time for community and collaboration to make this a great opportunity. There we go, perfect. I have another little poll that's not a word cloud, it's just kind of an open text box, which this is the second and last Slido poll if you want to participate there. And my question really is what do you feel you need to engage with Rubin citizen science? And using engage as a very broad term, this as somebody who wants to volunteer, who wants to bring it to their communities, somebody who wants to lead a project, engage in whatever way you are interested. I'm curious what resources you feel you need. So that will stay open until the end of the session. And so we want to move on to a little moment of just kind of getting kind of the creative side going, and we're going to have a little section in which you can either kind of talk to the people you're sitting with, maybe make a friend, about what a project might look like and how that might work, using Rubin. Also, in a moment that if you feel a little bit less chatty and you want to just explore some of the existing projects and kind of be inspired about some of the projects that are out there, that would be great. Just coming back to our word cloud for a second, I noticed that Galaxy Zoo is there. And Galaxy Zoo, of course, an amazing, groundbreaking, awesome project, but there is so much more happening, which I think is nice to remember to just kind of expand our options beyond, where the pathfinder of Galaxy Zoo is about where we can go here. So just to get us thinking, Aprajita and Aaron are going to talk about their CitSci projects for a couple minutes and just kind of reflect on some kind of lessons learned and ideas from there. So Aprajita, I'll let you take it away.
Thanks very much, Claire. So yeah, I'm going to talk a little bit about my experience with spacewalks, and this is a project that grew out of Galaxy Zoo. So I feel like I've been looking at it for most of my academic career, at least since Galaxy Zoo started. And this is kind of a project where we kind of learned from Galaxy Zoo where strong lenses were just discovered serendipitously, but then evolved it into a specific strong lensing search tool, which was then launched as spacewalks. So this is work done with Phil Marshall and Annaprita More, and recently Phil Holloway, who's my grad student in Oxford, has done a tremendous amount of work in the latest versions of spacewalks. But essentially, this slide just kind of summarizes what the problem is. So we basically have an image of HSC on the left, and then lenses that have been discovered in HSC on the right. So these are kind of the quality of images we can expect from LSST. But you can see in this kind of plethora of varied galaxies, finding these very rare and often blended strong lenses with the lensing galaxy is really quite a difficult problem. It's also difficult not just because it's hard to discern these features, but there's also a wide variety of features and morphologies, and only 1 in 10,000 galaxies are capable of producing a strong or a discernible strong lensing feature. So it really is an issue of getting through a lot of images. So if we could go to the next slide, please. So we tried to optimize an interface. So if for those of you who've tried Galaxy Zoo, you might recall that it's quite a long kind of decision tree process where you're going through many different steps, whereas we wanted to go through many images. So we optimized the survey for speed, meaning that we wanted to sift through as many potential lenses as possible. And so we just literally boiled it down to a yes/no question. So you see an image, it's presented to you, you say there's a lensing features or there's not, and you move on. Usually with one swipe or one click. And we also wanted to promote to the group, which I think was very important for us, was that this is really a crowd classification. So we actually take everyone's votes and we aggregate them with and kind of normalize them according to how well they're performing, to produce effectively a score for a given object that is based on the crowd classification. So just a comment on the comment in Slack about authorship, in talk about in the chat about authorship. So what we wanted to get away from was this kind of an individual discovering a system. Because again, because we're aggregating scores for whoever's seen this particular subject, it's very important for us to kind of lose that single person flag on discovery. Although there's definitely an inherent will, I think, amongst just us sociologically, to feel that kind of label of discovery. So we've tried very hard to kind of minimize that. So we always present things as a crowd classification, and we acknowledge everyone who's participated, because even, and I don't have time to really go through this, but even someone who's consistently wrong will provide as much information as someone who's consistently right, because of the way we've set up the kind of score probabilities. So that kind of means that everyone actually has an active role in discovering or rejecting, which is really the main part of gravitational lens discovery, any particular candidate. And we actually, while we don't add everyone to the publication list, because we have 10 to the 5 or more volunteers, we put their names on a public webpage so that that's affiliated with the publication. So again, hopefully building this crowd discovery model. So within Spacewalks, as I mentioned, we were the first project to kind of interleave a couple of features. One is instant feedback, which kind of acknowledged how bad we were at engaging with the citizens as the scientists running the projects, in terms of kind of giving them feedback, because that's really how they engage and they learn. They want to be involved with the scientists. They want to hear more about what they've flagged in. And those of you familiar with Zooniverse will know that there's this talk feature where you can actually go and discuss interesting things that you've seen, whether they're the target source or something else you've seen interestingly in the images, and they want to engage with scientists. So there's a very much a role in the science team, you know, being present on talk and giving feedback. But in terms of, you know, when we're looking at 400,000 odd images, it's very hard for our small science teams to constantly be commenting. So Zooniverse very kindly instigated this active feedback, which meant what we did was that we interleaved training images that I mentioned earlier, these simulations, into our classification stream, and they had associated feedback with them, such that when a citizen got it right or wrong, they received a pop-up message on whether they got it right or whether they should try again, or maybe pointed to different resources to look at where they might have got things not quite right. So that was kind of very important to us, and I think that also helped with our engagement with the community. And then the last thing I just wanted to mention is I think you can never underestimate citizens. I think they've astounded us in various stages throughout our various projects, and particularly there's always a small cohort who really want to get into the data. And actually with our first project, which was on CFH-TLS, we had citizens actually modeling the strong lenses that we discovered in our first project. And this was not part of the Zooniverse tool, but I just wanted to make the point that there's a will and an interest there in some cohort of the people that are classifying. There'll be as well another cohort that just want to get through and just look at images quickly. So there's a lot to learn. And again, Colin was talking about understanding his community. I think that's really important, because you'll see that you'll have a huge diversity in the people that are trying to work towards your project. Excuse me, could we go to the next slide, please? So just coming back a bit to how Spacewalks interacts with AI. So also related to what Brian was talking about. So here on the left, you just see some examples of kind of systems that were not picked up by the robots that surveyed CFH-TLS that were picked up by the citizens, just as an example. And this exists, you know, whether you're using a deep learning neural net, or if you're just doing kind of blue arcs against yellow objects. They all kind of have these areas where they're just not picking up systems. And so with Spacewalks, we've always had some level of machine activity as part of the running commentary on why the project is there. So we've always tried to be upfront. In the first one, we kind of pitched it as robots versus humans. And then more recently, we're really looking at it as a partnership. So our community have always known, I'm so sorry, that's really what they're doing. And the comment on kind of human pattern recognition, I think we've definitely seen that in this particular application. It may be less true in other applications, but with these kind of complex, blended, varied systems that gravitational lenses are, the pattern recognition skills of a human do currently, I would say, supersede what the robots can do. While the machines can find a huge number of sources, the purity is very low. And so that we still need human visual inspection. And the other thing that I think actually is on the next slide, we've also seen things like humans being much more versatile. Sorry, I didn't mean to switch to the next slide. I'll come back to it, but if we just stay on that one, humans have become kind of much more versatile in their training. So, for example, we'll see on the next slide that, you know, they can pick out green arcs and red arcs, even though they've never been trained on them, just through their intuition, which is something you'd have to have in your training set for a machine to pick that up. The other thing I'd just like to mention is, again, like we're evolving into this real partnership. And Phil Holloway, who's online, if you want to ask him more questions about this, he's done a lot of work in kind of calibrating scores, whether they're from machines or from citizens, such that we have kind of probabilities rather than just numbers that we can then combine to produce an ensemble kind of weighting of whether a system is a lens or not. And what he's found is that really you get the best strength from building these ensemble classifiers. It allows you to see where the deficiencies in the human visual inspection are, as well as what the AI and different flavors or different networks, how that may have been trained differently, are kind of not able to pick up everything, but this basically improves your completeness. So if we could go to that next slide now, please, which is just my kind of lessons learned. So on the right, you just see these examples of these kind of green strong lenses and the red arcs that were discovered by the humans that I mentioned a little earlier. So from our experience, I just wanted to take a few minutes for some takeaway messages. So data preparation is really important. So what you want the citizens to see, that can hugely influence how they perform. And that includes kind of colors, combinations of filters, but also the scaling of those filters. That basically takes a huge amount of time that I think is often underestimated. We typically spend a good 3 months or even longer thinking about what images to present to the citizens, and the kind of scaling in the PNGs takes a lot of time to optimize. In our case, as I mentioned, AI and machine learning plus citizens is very important. We are also thinking about this adaptive or the active loop that Brian mentioned, such that we're able to improve our training sets, to improve the performance of AI in an active way. I think going back to this thing about citizens as being members of your collaboration, we should definitely do that. That's what motivates them, is doing the science. It's not just that they're kind of en masse labor, you know, they really want to feel involved. So we do try and hopefully, I hope we've done that, kind of convey that message to them through our interactions. But I think the key issue in LSST, because we have this long baseline, is retention. And I think there are a lot of various strategies that you can use, but we do need to make sure that we're communicating, that we're engaging as the science team running projects, because we're just going to lose people if they don't get return. And that includes things like being on talk, doing blog posts, recognizing systems, keeping them updated as we get more and more results from the work that they're doing. The final point is just a rough scaling. So we also think quite hard about how we kind of phase projects. And this is particularly important in LSST again, because we have this long baseline, is how do you pull people in, as well as, you know, retaining the crowd you have, but also having new classifiers. And obviously over this long baseline, there are different strategies you can employ. For example, I think Claire mentioned, you know, they're motivated by seeing new bits of data. So you could have kind of campaigns that are either long term, but you could also have short focus campaigns. So we've kind of done a mixture of these. We know the kind of typical rate we can get, which is what you see there, the kind of 10 to 5 images in a week. But we've also done things like, you know, we want to get 1 million classifications in a week, which we've done. So again, it's about how you publicize it, what the motivation is, what the challenge you're setting is, but you can do kind of a mixture of these over the lifetime of LSST to kind of keep your engagement as high as possible. So that's all I wanted to say. Sorry, I took a bit longer than I intended, but yeah, watch this space. We're launching a new project hopefully in the next few weeks. I forgot to put the URL here, but it's just spaceswaps.org if you want to hang out and see any of the things that we're up to. Thank you.
Okay.
Yeah.
My slides are relatively brief, so time spent walking up here might be a significant fraction of the total time. Anyway, yeah, so I'm going to talk about a project that I co-founded back in 2017 called Backyard Worlds. And the whole idea of Backyard Worlds is to crowdsource the visual search for cold brown dwarfs. And the way we do that is to look for moving objects in infrared data from NASA's Wide Field Infrared Survey Explorer WISE telescope. Here are just some stats to sort of, and general things to give an overview of the project, but basically we've been quite successful, I think, at both engaging with a large swath of the public. So, you know, we have more than 80,000 registered users from all over the world and more than 9 million classifications. That's only from the original Backyard Worlds Planet 9 version of the project. We have a newer version, the logo of which is shown here, called Backyard Worlds Cool Neighbors. And the difference with Cool Neighbors, going along with this theme of AI plus citizen science, is that Cool Neighbors uses deep neural network analysis applied to WISE pixel level data in order to pre-select candidates, whereas the original Backyard Worlds Planet 9 just shows random sky patches. So we are also moving in this direction of incorporating more of the synergy between artificial intelligence and the human aspect as well within Backyard Worlds. I didn't put much about the actual science on here. Again, as I said, the way we identify these brown dwarfs that are nearby to us is by using motion as a proxy for nearness. So we look for things that have high Fock motion, that move across the sky in a visually detectable way compared to very distant stars and galaxies. But in addition to our public engagement success, we've also been very scientifically successful. So we have more than 4,000 brown dwarfs that we've discovered to date through Backyard Worlds, which is on average about 1.5 new discoveries per day if you sort of look at it over the 7 or so years that this project has been going. We've also been very successful at finding, you know, relatively high impact discoveries. Our discoveries have been followed up with pretty much all the premier ground and space-based telescopes, from, you know, Gemini and Keck to Spitzer and Hubble and now JWST. So I just only have one more slide here. That's some of the takeaways and lessons that we've learned or continuing to learn through Backyard Worlds over the years. One is just that visually assessing motion in time series astronomical images is a task very well suited for crowdsourcing. This was not especially obvious to me from the outset, and I'm glad it worked out so well. You could certainly imagine other tasks that might not be so engaging or that might not match so well with the human pattern recognition capabilities. And I would say that first bullet point there about visually detecting motion being so good for a citizen science project, it bodes very well for LSST, because there's all kinds of projects in that realm, from brown dwarfs to other types of high proper motion stars of higher temperature, and of course all kinds of solar system moving objects. So I think that bodes very well for citizen science with LSST. The second point here, I think, echoes very closely to with what Apogita was saying earlier, just a few minutes ago, about treating the volunteers as if they're, you know, just another member of your science collaboration and collaborating with them in the same way that you would a colleague who has a PhD. So I think one of the biggest keys that's really made Backyard Rules not just have a high nominal number of classifications on the Zooniverse, but really have as high scientific impact has been engaging with the volunteers beyond just the Zooniverse interface. So we don't just throw the data on Zooniverse and ask people to click on it. It goes way beyond that as far as really trying to get to know the people who work on the project, interact with them, in many cases mentor them in relatively advanced aspects of the project, like writing their own telescope proposals, writing their own peer-reviewed journal papers, doing their own sort of side projects, maybe where they're like going onto an archive such as URSA or some other publicly available data set and actually doing their own data mining in addition to just doing the classification on Zooniverse. So this picture here is showing one of the key examples of this, of how we sort of onboard folks from just being someone who puts on stuff online to someone we know very well, we mentor through the scientific process, and who contributes a lot scientifically beyond what they could do just as an ordinary Zooniverse user. And so every week we have an 1.5 hour call with the science team, and science team for us means the professional science team, plus we invite a group of about 300 super users, we call them, or advanced participants, we also call them. And so usually it's actually mostly dominated by participants who are volunteers rather than professional scientists. And the way that we actually get in touch with these folks is that in addition to the Zooniverse classification interface, we also have a Google form that we provide where relatively advanced folks can go and say, this is an object that I'm really interested in. Here's some more information I looked up about it online. And then in addition to that info about the astronomical object, they can also optionally provide their email address. And that's where we start getting contact information. That's how we can start getting to better know people. The other last thing I say is that, I mean, Backyard Rules is definitely very interested in doing an extension or spin-off focused on Rubin and LSST data. To me, it just makes perfect sense because I think proper motions with LSST will be great because it's going so deep and it has so many visits to every piece of the sky over such a long time baseline. Going back to the original question that Claire posed about resources, one of the main questions to me in my mind that comes up is how would we think about funding this work to create either a totally new project or a spin-off project that leverages this Rubin Zooniverse pipeline and the LSST data. So to me, I think about this a lot in terms of the analogy to NASA also has a partnership with Zooniverse. And NASA is also trying to encourage lots of new PIs and researchers to create these new citizen science projects. And one of the ways that they do that is they have something called the Citizen Science Seed Funding Program, which is a NASA Roses element that will give you something like $80,000 to launch a new citizen science project leveraging Zooniverse and NASA data. And so, you know, for a while now, I've wondered, could there be some sort of parallel to that within the Rubin sphere of influence? And, you know, that question is a little bit over my head as far as actually finding funding for it. But, you know, to me, it's come to mind of whether LSSTDA could play a role in something like this, because the sort of small seed funding, you know, $20,000 to $80,000 is kind of exactly the right amount to hire a couple of interns for a summer or two and leverage the Zooniverse tools and whatever data set that you have to build a new project. And so yeah, I think it would be great if there was a roadmap sort of how someone who wants to do this could get a little bit of funding to get them over the hump between just wanting to do it and actually doing it. So I'll leave it at that. Thanks.
Okay, due to the great insights and discussion we've had already, we're slightly running over time. So what I would like to do now is just do a very abridged version of just a slightly interactive moment. So I think what I would like to do is we take 5 minutes to either chat with the people around you about what you've been excited to do about a project, or hop on Zooniverse for 5 minutes and just have a look at a project you haven't looked at before, and see if there's anything that is cool, interesting. It doesn't have to be astro. One of my favorite projects is the Elephant ID project, which looks at the shapes of elephant ears. I think it's great. I think it's out of data right now, but that's good. And just kind of take a minute just to kind of think about, you know, slightly kind of outside the box of what could Rubin CitSci look like for you, either as a volunteer, as somebody who's excited to hype these projects, or somebody who's excited to run one. So Or just chat to your neighbor. Don't have to actually open Zooniverse and have a little think about what you're excited about. So maybe we'll just take 5 minutes to discuss, and then maybe as a group just discuss any insights for a few minutes, and then we'll talk about what resources we have ready for you. Everyone's very quiet because we can all ask questions if they have
I
to.
think it would be good to do like in the early days, like prop promotions. The early on, so at the beginning, you're not gonna have.
So I'm something new to Zooniverse. I've never used it before, but when I was looking at the website, I think definitely anything physics related because I'm a information science. So when I was looking, I was looking primarily at dark energy. I definitely see that how the universe is expanding, early universe, and science.
So are you interested in getting involved?
Yeah, but I think that's pretty easy. Yeah, I'm already doing it. Maybe I should say
in my institution, they have not covered students who haven't been promoted or anything about it. So this is probably something that I have to talk with them next round. So can we, expand this to community within my institution and getting like more students on board?
Yeah.
She doesn't want to be just an engineer.
I guess what would be challenging about what you're talking about is that we're putting in we're going to utilize this data.
Yeah, but
Not the other data. But it's still like, my understanding from listening to you last year, since that session, where we had the wrong was. Not have the data, so they were really when you go through the like where the content of it is coming from. That's also
Yeah, I'm just a manager over all of it.
I think that's the
Yeah.
So why you're allowed to.
Oh no, I'm an undergrad student.
Yeah, I mean, I guess.
I'm an
In the time that you were going to be doing this, there'll be data.
Oh, great. Yeah, I want to join this session because I'm a little more info about it. Because I think definitely starting sooner than later.
So it's primarily built for looking at time series all over.
There's no project. That's why we started. That's the one over there. We talked about. You mean to look at what I haven't got around. I worked on side by side. Yes, that's not.
Picture of motion.
Well, I haven't tried this. Like I have pictures of this. It's like fingerprints that I didn't.
I'm part of the extent.
Yeah, sure. Well, that's what I'm saying. There have been many discussions, but I haven't tried it.
But I am really.
Never get to
Claire, we were talking about in the early part of LSST, you
I
might
love
want to have a
the wide
project,
scope of
especially if you need a
Zooniverse. I
time
had no
baseline that
idea
like
it covers so many
shows
different
EPAN data and then shows
And when
early
it
LSST. I guess it raised the question of how well that aligns with the current notion of the Rubin Zooniverse type solution. I would guess is more looking at all Rubin data.
The other system that's similar to
So if you can combine these
it's the same sort of thing where you can
data,
define a job.
so that would be.
I think RSP would probably allow you to query out external API.
Yeah. And you can
Like a
also,
Norlab API.
Search and
you can also like find things in other ways. Like there are good ways to do that, but I think you could just
Go back to when I was. And we're all.
breaks it up in small tiles and asks people, is there a fire?
Well, or people, whatever, but I remember like.
data, but then there's this data.
So
Project.
it's a slightly different thing.
I imagine it would be nice if the game was like.
Yeah, and then.
The Galaxy is much more.
Oh my gosh. Why not?
My one line.
I'm like, no, you're wrong.
Yeah, I've had success querying out to like Astro Data Lab, Norlab from in RSP, so I guess the function.
Yes, that's why I think.
Yeah.
Cut out service.
And then.
that I would want.
So right now you pull whole images.
I hate to
Oh, yeah.
interrupt the nice discussions that are happening, but I do want to leave time just to get to the last part of our talk. I just wonder if anyone wanted to volunteer just like one or two lightning fast talks or takeaways of anything of projects you looked at or things you were discussing, a question or comment. If there's any online or in the room, anyone have any thoughts? Did anyone find a fun project out in Zooniverse? There's lots of good ones. Yeah, I appreciate all these conversations, and I'm looking forward to discussing with you all more takeaways. I would like to now just hand it over to Becky, who is online with us, who can talk about what we've built for so far for supporting project development at Rubin. So I'll hand it over.
Cool. Thanks, Claire. Can everyone hear me?
You sound great.
Okay. Thank you. Yeah, so everyone has done a great job so far motivating like the why of citizen science, which we saw on the last slide. Now we're going to talk about the how, which is like what we've been doing as members of the EPO and the CitSci team to support PIs to better actually be able to do this work. I haven't been doing all of these things that I'll talk about, but I plan to touch on just like a number of different tools that we've created to facilitate this whole process. So here we have a Rubin logo and a Zooniverse logo, and the whole big picture idea is how can we enable PIs to easily send data between these two entities, because it turns out to be pretty hard if you're just going at it alone. So one aspect, actually, Claire, can you go to the next slide, please? Which just has a little bit more info. Thank you. One issue on the left is handling the data. So we've created a pipeline to connect data directly from the Rubin Science platform, which I call the RSP, to Zooniverse, and the other way around as well. How do you go and grab data from Zooniverse and bring it down to the RSP when you're actually ready to do your science with your classifications? So in addition to providing software to do this, we also have provided a number of documentation and support tools that continue to evolve as we approach data release date. All right, next slide, please. Okay, this is like the most dense slide. I wanted to really outline some of the resources we have going on. So this first bullet point is the Rubin.CitSci software package, which is pip installable. And we show some examples of how to go and grab that in our notebook tutorials, actually. This package contains a lot of the utilities for working with the various tools that send and receive data. Things like the Panoptes client, if you're familiar with that for Zooniverse, that's included in this package. Your ability to like log into Zooniverse through your Python notebook that sits on the RSP, stuff like that is all included in that Rubin.CitSci package. The second bullet point is we've also created a number of notebook tutorials that will walk you through how to send data to Zooniverse and how to retrieve data from Zooniverse. And those touch on a number of different useful aspects of this. This whole repo is known as the Citizen Science Notebooks repo, and I've linked it here. There are various different notebooks in there, and we continue to expand these resources. So I'll talk through today our basic notebook, which is notebook 01. This just shows a very basic example of sending imaging data to Zooniverse. And then I'll also talk through the slightly more complex example that uses a flipbook. So we consider this to be a different data type. This is, for example, if you want to do like time series data, you might want to send a bunch of images of the same object at different like moments in time. So this is our example of how you might do that for a variable star. And that's the O2 notebook. And we have a lot more notebooks under development, including an alert stream broker example. And we're also working on a classification aggregation example. So that classification aggregation would be, how do you actually go and grab data that's been classified from Zooniverse and aggregate all the volunteers' classifications into like one answer for each subject. And this yellow box on the right is reminding everyone that if you want more details, which I don't have time for today, there's actually a full walkthrough of that basic notebook example on rubinobservatory.org. So you can go watch that video that's me talking a year ago about how to use this entire notebook tutorial. And just to summarize all of these resources, I will say the whole point of this is we want to reduce the learning curve for how to actually interact with RSP and Zooniverse. Okay, ready for the next slide. Okay, this is a screenshot of how easy we're trying to make this, how simple and approachable. So for example, this is a screenshot from the basic notebook, the first notebook that's in this repo. This is towards the end of the notebook, once you've like created your screenshots, or sorry, once you've created your cutout images and save them to this batch directory. This is an example of how easy it is to set up a path to the zip file. And then section 4.2 simply shows this is like the sending the data cell. It's like really that easy. These both use the citizen science pipeline that I talked about before. These are utilities from that pipeline. And this lower cell will like link your data and we'll send it to the education data center, and we'll create that link between the EDC and Zooniverse, so Zooniverse will be able to display your images. All right, next slide. This, oh, I forgot I won't be able to control this. This is a screen capture of me showing what this looks like on the Zooniverse side. This is from the second notebook example, which is the flip book. So here I'm actually viewing my data on Zooniverse, and this is a collection of a series of images of a famous variable star. I think it'll play again. Thanks. Somebody's controlling this. Claire. Yeah, so simply you can click into the subject set here, view the image, and you'll see that the flipbook example will send this collection of data. And of course, these examples are designed by us to be built off of by you. So this is like a good starting point. We want to provide examples of different types of data. And then we want users to talk to us if they want to see maybe a third example of a different type of data. So we're open to developing things at this point. Okay, next slide, please. This is to mention that we're also creating a number of helper utilities. These helper utilities are designed to help you begin your project. So a lot of info is actually is required when you start a project on Zooniverse, including things like introduction to the science, introduction to Rubin Observatory, things like that. And our thinking was that a lot of this data is actually will be shared between different Rubin projects. And so the idea of this CitSci pipeline.create new project from template utility is actually to give you a good starting spot to begin, which you can then edit if you want to change something, but it will provide a lot of general things that will be shared between projects, such as like social media links, educational resources. And furthermore, our hope with this is that volunteers who are doing classifications will actually have this like roadmap to travel between different Rubin projects. If they have a really good time on one Rubin project, then they can like use this linkage of, if we end up linking the Rubin projects visually or with like the introduction to Rubin Observatory part, they'll be able to follow that path between projects. All right, next slide. And just a brief list of other utilities we're working on right now / will be working on in the future. So I've been working on an aggregating classifications notebook example and accompanying tools. And this is building on a lot of work that the Zooniverse staff has done already with these Python tools. We want to create A clear path forward for people who have never used aggregation tools before so that they can have a jumping off point to do their project with big data. We also have plans for an early retirement of subjects. So if you have like time sensitive data, or like, I mean, that's the whole nature of Rubin Observatory is we're always having new observations. If you want to retire subjects that have enough classifications so that your project can continue to see new subjects, this early retirement tool would be useful. And then we're working on planning for an alert broker tool to work with the alert brokers. All right, Claire, I think that's all I have.
Thanks, Becky.
Thank you.
And I'll just emphasize that, yeah, there's more details on our website about all of those and how to access them. Good question.
Yeah. So other questions. Is there a data run issue we could be aware of for sending data from RSP to users?
Yes, that's a good point. Yeah, so of course, we have to be aware of the fact that a lot of Rubin data is proprietary for its first years. And so one of the other things that we have developed is some documentation and guidance about what data can be shared and how to share it. And also we're, as a team, available to kind of support and discuss about what data is okay and guide our project leads through that process as well. So just to summarize here, the fact that we're trying to build tools and a community for the Rubin Observatory. Both this is a community of volunteers and a community of project leads. And our team is here to help you make projects happen. Of course, we have a small team. It would be fun to do a bunch of citizen science projects, but we obviously need our science community to really take the lead and get all the amazing areas of science that citizen science can touch on going. So why are we doing this? We're helping our scientists. We recognize the fact that starting and maintaining a project is a challenge. And we're trying to make it easier to start a project using Rubin and also give some support and guidance on best practices to maintain it through the survey, if that's necessary for your project. Also, we'd like to continue to reach a broader audience. This is in line with EPO's mission and priorities. As I mentioned, this is a great way to bring more people to the exciting time of discovery with Rubin that we have around the corner for us. And also, I would say that, we are, as part of Rubin, we are faced with data volume, also challenges. It's a good problem to have. But the fact that as a project lead, this is going to be a challenge on how to navigate all that data. And from the public's perspective, we want to make sure that the public interest is maintained and we have momentum for all the exciting projects to come. And so valuing our participants' time and effort and honoring that is really central to our efforts here. And so just summarizing again, we're providing this pipeline, support from our team, communication and engagement strategies, and we are hoping to have project leads who are excited to share Rubin with the public. And we're hoping to have coordination, collaboration between projects. We'd really like to make every project an awesome experience for volunteers and have them be all meaningful as we can value and respect our volunteers' time. As well, CitSci is a great space, as I mentioned, to have more people participate. And so equity, inclusivity, diversity, and accessibility initiatives are great to add. But again, these are not something that happens passively. And as a team and a community, we'd like to support these initiatives and help guide forward. So one of the things I want to mention is the fact that we are excited to kind of connect what's going on in the citizen science to some of the other EPO initiatives. So I'll just mention a couple here. So of course we have a social media and web presence, and we have a growing following that hit 10,000 followers today
on Instagram.
And so it will continue to grow, and we hope to use that to encourage people to participate. We're working actively on preparing the public for Rubin and the science to come through things like science releases or explainer videos, and are hoping to start a CitSci talk series very soon. One of the things I'm most excited about is connecting citizen science to our formal education program. So the formal education program is designed to bring Rubin data into the classrooms for senior high school to first year undergraduate students. And these investigations are full of support for teachers and educators about how to talk about Rubin science and everything like this. And I think citizen science is a great addition to this. It's another way for students to get involved and go beyond some of the investigations we've developed already. But also the investigations provide the education support that a teacher might need to have these investigations in the classroom. It's a really great space. And I really like comparing these two maps. So the one that I showed before is the current Zooniverse volunteers, and the one on the right is participants in the formal education educators teacher workshops. So these are teachers that have already participated in the formal education program. And when we look at South America, there is many teachers that have participated in this program, and it would be really exciting to invite their students in classrooms and lecture halls to be a part of our Rubin citizen science volunteer community. And so we'll just wrap up here. If you're somebody who thinks they might be a future project lead or part of a team, I would encourage you to keep planning and thinking about the data, accessing some of the resources that we've mentioned that are on the website, and we're adding more. Reach out to myself or anyone else on our team about what things we might be able to provide or questions that you already have. If you're somebody who might want to volunteer in the future, or if you're somebody who knows people who they might want to volunteer in the future, whether that's friends, families, students, stay tuned for this series of talks, which are hoping to get on the road very soon. We have lots of things on social media. We also have this public-facing citizen science page. On here, we are highlighting a couple projects that are, I would say, Rubin-ish. So there's something about them that is kind of looking forward to Rubin, either something like Backyard Worlds, where a Rubin version will be great to see in the future, or like Superluminous Supernova, which uses the laser alert broker. If you have a project that you are currently active, you would like us to have links there, we're happy to do so, and we'd be excited to discuss how it's forward looking to Rubin. And finally, if you just identify as a future Rubin CitSci hype person, which hopefully we all are, if there's resources we can provide, things that you want to see, places, people and places we could talk to, support, please be in touch. I think we're going to need lots of participation and eyes and energy to tackle Rubin's data set, and I'm excited to get as many people involved as possible. So I will just wrap up here, but I will see our other Slido poll, which I think has a lot of results. So I'll show. Okay, so the question was kind of what resources you need, and I will admit I have not looked at these yet, but looks like there's lots of great comments. So again, AI and machine learning tutorials, machine learning, alert system, user-friendly tools, ways to integrate training. So this is great, and we really appreciate your input, and I'm really excited to hear a little bit more about all the things, the ways we can support you. So I will just put up my conclusion sign there and the conclusion slide there. And yeah, we have about 10 minutes left just to continue the discussions that started earlier and ask any questions anyone online or in the room. Thank you very much. Are there questions? Oh, yeah.
So Apergita talked about this a little before, but like you mentioned in your project, you have like 300 advanced users and like what, 8 million volunteers in total?
On Zooniverse, I think it's like just under 3, but
okay.
Yeah.
But how do you credit all these people like in papers and stuff?
Do you want to comment, Aaron?
I think maybe the 300 was coming from what I said, but yeah, it's like 300 out of 80,000. We have a collaboration policy in Backyard Rules, and generally, yeah, it's a good idea. One of the lessons we learned is a good idea to have a collaboration policy earlier rather than later. But our collaboration policy spells out how you get co-authorship, and basically the way we do it is if we're writing a paper presenting new discoveries and you're the discoverer or co-discoverer of any object on there, then you get to be listed as a co-author. that's pretty much it. But yeah, I mean, there's still like questions about how you could more broadly acknowledge everyone, right? I guess, and I don't think we really thought that at all.
Aphrodita, do you want to add anything? No pressure.
So yeah, I think what we currently do is that we have kind of a group of Zooniverse and our citizen moderators on talk who have kind of publication authorship. I think because of our crowd model, we're not adding just people who've seen a particular source, and that's also because, you know, when we publish hundreds to thousands of sources, it's very hard to add all those names. So as I mentioned, we just have a web page where we list absolutely everyone who's even clicked once. That doesn't necessarily motivate those people who are, you know, motivated by seeing the thing first, and so they kind of get lost in that sea of names, which is not great from their side, but I think it's the fairest thing to do from our side.
Yeah, I wanted to add two things. First, just to comment on including citizen scientists in papers. I've been very involved with the Unistellar Citizen Science Network that was mentioned earlier, and I think I had about over 200 citizen scientists co-authors in paper, and it is challenging to do that. And what we've done for that, I guess, relatively small number of people is, you know, open a channel of communication with those citizen scientists that are involved. These citizen scientists were participants that actually collected data with the unistellar instruments that was used in some of the papers that we have published. And although it's a challenge, it is so rewarding. I had over 20 high school students included as co-authors, and that's changed their lives. And a lot of them have gone on, or going on now currently, to go pursue careers in astronomy and astrophysics, or just felt, you know, very accomplished about learning science by actually doing science. And then that segues to the second thing I just wanted to add, just how exciting I think it is that the Rubin Observatory has built this EPO into from the very beginning, and including citizen science and in Zooniverse. I like to kind of think when we start something, it's good to kind of envision where we'd like to go and some things that we might be excited about seeing, like in the years to come. And with that, I would think about like kind of a grim picture at first about our state of our K through 12 education system, and how we have about 91% of our US population that attends public schools. But in just the past like 5 years, it's been estimated that only 40% of US high school students actually have completed a physics course. And then from that, we hardly have any astronomy. So students don't really take astronomy. In fact, that's been a common thing in our schools for the past like 100 and some years. And astronomy is something that really excites us. When we talk to young people, they want to talk about, are there aliens out there? What's life like on other planets? Or, you know, what is our place in the universe? This is the thing that excites humans at such a great level. And there's a growing also like distrust in public education. In fact, there was a Gallup poll in 2023. It's been going on since 1973. And the 2023 Gallup poll showed the lowest confidence in our public education system in America. As a public school teacher, I've taught in high school public schools. Most recently, this past year, teachers are leaving at higher rates than they have forever. They feel like they're not cared about. And having programs where we're engaging with the community of teachers at the K through 12 level, at the public school level, can really change things, especially if we're inspiring them about the universe and the great discoveries that Rubin is going to do, and being inclusive, like the vision of Vera Rubin. So there's a great opportunity here, I think, for us to really focus on empowering the foundation of the students that go to our colleges. I hear a lot of people saying, oh, we are going to create education opportunities for college and beyond, but who goes to college and beyond? It's high school students. The majority of the country goes to these public schools. So I just see this great thing that we can do if we just all get on board for it and find some of those funding opportunities to engage these people, like Aaron was saying. And I hope through philanthropic and other things, we can do such a thing.
Yeah, no, I appreciate your comment. And I think this highlights the fact that the connections from the ED program, those are targeted, I think it's grade 8 through to grade 12, which is, and first year university, whereas most of the citizen science projects are kind of at a level where just dropping that project unsupported into a classroom is probably a bit much, but connecting to that formal education program and you have all those resources, like I envision a super cool combination of a citizen science project about type 1a supernova and our exploding stars investigation, which could, create those opportunities, which would be, really awesome to see. I feel like I saw a hand on Zoom, and I don't know if it disappeared or if it's just out of the corner of my eye. But is there anyone on Zoom who wants to unmute and say anything?
No, that was just applause.
Okay, perfect. It was just in the corner of my eye. But yeah, if there's any comments from Zoom, we have a couple minutes left. Otherwise,
let me ask a question, if it's okay. We chose Zooniverse through Rubin, and that was a great idea, I think. But are there any other platforms that someday would be worth working with? Or is Zooniverse really that elephant that is really the best and the one we should stick with in the long term?
I think that there is the option to have other types of citizen science happen as well. But I think Zooniverse is such a natural fit with kind of Rubin's priorities and our connection that it makes a lot of sense. So I think, it's not we have no interest in other forms of citizen science, but I think as a way to get started, I think Zooniverse is kind of really the most natural fit. We were discussing with Dan actually about unistellar and then the fact that annoyingly the overlap range between the depth of the unistellar telescopes and where Rubin saturates is not that big, but it exists. And so, there's a space there where there might be some interesting options. But our current focus is Zooniverse, but there are definitely other options to explore down the road.
That makes a lot of sense. I'm in favor of that too. I'm thinking more along the lines of year 3, 4, 5, as we're really starting to move forward. Folks like Unistellar, as we all know, have a much higher learning curve. They need a lot of training to be able to use these spiffy telescopes, right? But over time, that might be the way to increase even more participation beyond just being online, but actually being in the sky, or any other techniques for that matter. A lot of things are going to be developing in the next few years, I think, thanks to all the AI revolution. So thanks.
I'll just quickly say the unistellar telescope learning curve is actually really small, Charles. With the apps, the unistellar network will send a notification and a student can just click on a button. It auto-populates the telescope with the coordinates, the camera settings, and they can literally press a button and get the data from an exoplanet, transient, supernova, a comet, an asteroid in the solar system, and then another click of the button to upload that data to the cloud to the science teams. And yes, there's a small overlap with what Rubin Observatory can observe, but if we have a supernova that goes off at 18th magnitude, then that's going to get brighter over time, and you still need these follow-up networks to look at it. And there's another engagement piece when people are actually observing with a telescope, collecting the data themselves. That's more motivational than taking data that was given to you.
Right. That's super cool to know. Thank you so much for sharing that.
Yeah, no, we have very exciting times ahead, and I think it'll be exciting to see kind of what things we can develop as we start getting data and have hopefully very successful projects. So just keeping an eye on the time, we're at the top of the hour, so we'll wrap up here, but I would love to chat with any of you and all of you about any of your thoughts for the remainder of the week. So thank you very much.
Thank you, everyone.